So for our link, we chose to connect two Arduino Unos using UART communications, which is common in embedded systems, even though it's not often seen in network applications. The reason we chose the Arduino Uno was because we had experience from previous classes with how to assign the ports and pins in order to communicate between Arduinos. Another reason we chose it was because of its highly customizable interface. You could change the baud rate as well as which ports are sending and receiving, so such that you could potentially have a multiple port setup sending and receiving data to multiple different hosts connected via this UART link.
I think I found something.
Rx goes into TX, and then Rx goes into TX, and then this ground goes into this ground, and then you hook up power.
Basically, we're sending this every 10 seconds. This is the transmitter, and then this is the receiver, so it's going to receive data. So we're going to connect these pins. So first we're going to connect, this is the transmit from my computer, and then we're connecting it to Rx, and then we're connecting it to this one to TX, and then we connect grounds, and then let's see if it works. There we go. So we have connection. It printed our little ASCII message, and it should send every 10 seconds. There we go, it's sent again. So here I'm going to show you how our transmitter code and Arduino work. So first, in our void setup that runs at the start of our uploading to our Arduino, first we have this serial begin line that sets our baud rate to whatever we want. I set it here to 115,200 bits per second. And then I just delayed it for 2 seconds to make sure it synchronizes correctly and has enough time for each instruction to load. So then we have the serial print ln, and then our little ASCII sequence that then gets transmitted across our TX pin to our RX pin on the other Arduino, and it sends this little ASCII computer that I obtained, and then we just delay for 10 seconds. So it sends this ASCII message every 10 seconds, and then it should show on the serial monitor once here, and then also on the receiving computer and Arduino.
I am going to explain the receiver. So like before, for the transmission, we are using the serial begin, and we are using 1152,000 band, and that's in our setup function. Pretty easy function to do. And then after that, we go on the loop where if the serial is greater than 0, it'll print out the message from the or whatever message is from the transmitter, and then it will print out receive, and then once it prints the receive, and then it will print out the message that's from the.
In conclusion, we were able to successfully implement our link using 2 copper jumper wires with a third wire for a common ground between the 2 Arduinos. These jumper wires were for both an RX and a TS link between the two Arduinos. This was because we had to be able to both transmit and receive on both Arduinos throughout development. So throughout development, we were able to debug through synchronization issues with the Arduinos, because we would have to work through bugs. If one Arduino was listening when the other wasn't ready to transmit, then we would have to work through errors. Or if we had the Arduinos flashed but plugged in when one Arduino wasn't flashed, then we would have a long stack trace of errors, and it just wouldn't work properly. So we had to flash the code and then plug it in afterwards. So this showed us that synchronizing a network link could prove to be a difficult part of getting it to work and terminate properly. Termination was also something that we were able to get working. We just ended up using the default RX and TX pins on the Arduino.